Hello, good morning, class.
Good morning, sir.
Good morning, sir.
How are you all doing?
Very well, thank you.
Very fine, sir.
Do you know I've missed you guys?
We miss you too, sir.
Yes, sir. I wish you to, sir.
I'm sorry for not having class all this while. I have other lectures. Some of my colleagues conscripted me into, and well, it's anyhow. Let's start. Let's see what we can do. So I've uploaded your lecture materials on this topic online. I hope you found it. Have you been able to see your lecture materials on this topic?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So I have one of the lecture slide in PowerPoint, another one in PDF, and another PowerPoint material with an audio. So that one, I shared it on my Google Drive with the link provided on LMS, so you can kindly download so that at least after the class you can have something to fall back on. So can we start the lecture proper now? So I have about 58 students participating. So let me start because of our time. All right. I want to welcome you again to another class. And this is our first online lecture. So our topic will be functions. Functions. Every programming language has to treat this topic, functions. Every programming language needs to consider variable declaration, decision making, functions, array, and the likes. So functions in C++ is a very wonderful topic, and I would like us to look at it properly, pay maximum attention. All right. So what is functions in C++? So a function is a complete section of C++ code with a definite start point and an end point, and a function has its own set of variables. So a function has its own what? Set of variables. So whenever you're creating a function should be designed so that it has one primary task to accomplish. You must write a function so that it solves a particular problem. Let's say you can write a function to accept input from the user. You can write another function to compute your CGPA, another function to write the CGPA to the string. You understand? So you must organize your code so that it will be neat, so that people can actually follow you as you write your code. Because most of the time, the lifespan of a software elapses the programmer. You might start writing a code, or you might be part of a development team. What if you exit the company? You're no more working for the company. Someone must be able to sit down and look at your code and understand. So you must organize your code into modules, which are called functions. So your function should be designed so that it accomplishes one task. So most programs consist of many functions. All the programs you write always consist of functions, and each function may pass and receive information from other functions. So there's layer of dependency between functions. One function will pass information to another function. So a function is also a subprogram that acts on data and often returns a value. Now look at the word. A function is what? A subprogram. Your entire code, instruction you write to your computer is a program. A program, a set of instruction. But in your code, you are going to have a subprogram that is called what? That is called a function. So if it's a subprogram that acts on data and often returns a value. It's not every time that a function will return a value. You will see as we move on. So before we talk about functions, how have we been writing codes before? We can all understand that most our programming method has been sequential. We've always been writing sequential programming. As you move on, we will see what we call another dynamic called object-oriented programming, OOP. But for now, we've been writing sequential programs where our programs are read by the compiler line after line. So before functions, life before functions, how have we been writing code? Assuming you want to compute the average for two subjects, you want to compute the average. Maybe you're a programmer and you want to find the average of first semester, second semester, and third semester, or first term, second term, and third term on two subjects, let's say maths and a science subject. So what do you do? First, you have to declare the variables. You have to declare the variables maths, math 1, math 2, math 3, or you can give it a name. In this case, math underscore SC1, math underscore SC2, math underscore SC3. Maybe math for science students, okay? And the third variable you are declaring is the variable called math underscore average to store your average score for that math subject. Do you understand? So after doing your computation, you have to store your average score. So a variable must be declared to help you store or capture the information. Also, you are going to create variables to store your science subject, okay? Science subject, let's say biology, you know. So SC1, SC2, SC3, and SC average. So what we're trying to do is we want to calculate the average for two subjects. So let's say the subject is math and the subject is biology or science. So what do you do? To carry the user along, you ask the user to input the 3 math score. Okay, so yeah, scene. So yeah, the user inputs their score. So for math 1, for math 2, for math 3. Maybe for the math score in first term, the math score in second term, and the math score in third term. Then this line of code computes what? The average. This line of code compute the average. Now, you can see, look at this section. We divided it we cast it, we divided it by 3.0, which was casted at float. This will help us give us the real value. Do you understand? It will not truncate any decimal point. But assuming you said maths, you added the math score divided by 3, it will give you a real a whole number. That is to say, an integer value. So now this line of code display the average score, right? Because math average holds the average score, right? We are now displaying it. So also for the science subject. So also for the science subject, you are asking the user to input the 3 science score, and this the score is obtained by this line of code. You can see the cin with the input extraction. You can see this input extraction still works for the 3. It's just like saying scene for subject 1, SC1. Do you understand? Scene SC2. So rather than doing this, you can just make it a line of code. So the user will input SC1, SC2, SC3, and from here you find the average. The average is now stored in science underscore average, SC1 underscore average. you display the result. You can see this how we've been doing, or even if I ask you to compute the average, this is what you will do. So let's look at an improvement. Let's look at an improvement here. So what was the improvement? Since you're getting the input for let's say three terms, you declare them as, let's say, subject 1, subject 2, subject 3, and you have a variable average. This, you want the user to continue to compute the average as long as he wants, right? So you declare a variable char, and the value is y to represent yes if you want to continue. So you make a decision while the answer given by the user is equal to yes. Do you understand? You can see we are making decisions. So you are having double equal to. It is not a single equal to. If it's a single equal to, it means it's an assignment. Do you understand? It's an assignment, and it will always loop to eternity. So, but because we are making a decision, you have to use a double equal to. So while the answer given by the user is equal to yes, do this. So it will always ask for the user to input 3 score, right? After imputing the 3 score, it computes the average and it displays the average. Now, it asks the user, do you want to do another calculation? Maybe this first calculation is for science subjects, let's say biology. Do you want to do for math also, right? So it will also accept input for math, first time math, second time math, third time math, right? So it continue as long as the answer given here is y, it will, any other key, any other key is not y, right? So it will truncate. So this is an improvement, right? So you are just having a single loop asking the user for the 3 score, and it's computing the average. All right, so live with functions now. What's the beauty about the function? And again, one thing I want you to note is that in our main function, which is the boss of all function, main function is also a function, is the boss of all function calling other function to operate. It's just like the supervisor saying, okay, you function, you are next to operate. Function 2, you are next to operate. Function 3, you are next to operate. So you can see that in our main function, this is where execution starts from, right? You can see how cumbersome or how cluttery the codes are. As you be, okay, just imagine you are writing codes and hundreds or thousands of codes, and you are putting all your code in the main function. It's just what we call spaghetti code. In programming, we call it spaghetti code. They are not just well arranged. Everything is just scattered. So we call it spaghetti code. So for you to debug, it's going to be a whole lot of problem. But with functions, you can rightly organize your work into what? Into section, into compartments, and those compartments will carry out a specific task. So let's look at live with function now. So a more efficient technique for the example above is to use separate functions for specific tasks. So it is possible to separate the tasks so that there is a function to get the score from the user, right? Another function to calculate the average score, and another function to write the what? To write the average score. So your program, your entire program, you can break it into sections called functions, where each function is performing one task or the other. So for the program we treated earlier on, so we can just break it down and say, okay, let me have a function to get the score. Let me have another function to compute the average, and let me have another function to write the average. So This techniques actually simplifies the main function greatly, right? The main function, it simplifies it, and each task is performed in a separate location. Each task is performed in separate location in the program. That is to say, each task is performed by a function. So the program below, which we are going to see, shows a blueprint for a main function that uses what? Your own user-defined function that uses customized function for performing certain tasks. So I want you to know that many programming details are left out. So you don't take the code, hook, line, and sinker. Let me see. I need to mute everybody. If you can mute, if you can mute yourself, let me see. Okay, mute all. Let me mute all. Okay, so looking at live with functions now. Looking at live with functions, you can see we've removed hash include IOStream using namespace std and the rest. We are just starting with the main function. We're starting with the main function, and okay, someone is raising his or her hand. Who is that? If you're having a question, kindly unmute yourself and ask. Anyone? Anyone? Are you all following me? Let me get a feedback from you. Are you all following me? Let me get the feedback from you.
Yes, sir.
Yes, sir.
Yes,
All
sir.
right.
Yes,
All right. All right. Thank you very much. Thank you very much. So live with functions now. So look at this. The first is to initialize the loop. Yes, we create a variable of the type character, right? For our loop. Now this is where the loop begins. You're asking the user, okay, if you want to continue, press Y, else. So look at this. This our entire code has been broken down into 3 functions. Now this name is your own name. You give it your own name so that you know what it does. So the function now, the first function name is what? Get trace scores. The next function is find the average. You might write compute average. You can decide to give it compute average. Do you understand? The third function name is what? Write the result. Write the result. So you can see how slick, how simple, or how simplified the main function is. Main function is. Do you understand? So live with function is wonderful. Now, each of these function, when it gets called, it gets called in the main function, then it will go to the body and execute itself. Do you understand? It's like you're summoning it up. Oh, get trace score. I'm calling you now. I want you to go and perform your task. So get trace score will, we will talk about the function, header line, and body. Get trace score will then go to a section and perform its function. After get trace score is done, control is passed to the main function. The next function to be called is what? Is find the average. Find the average. So find the average also perform its code or execute its code. When it's done, it comes to write the result. So you can see it's just like this. The main function being the boss of all function cannot, putting your code there, it means the main function is actually doing everything. So why can't you just break down the whole task into functions, into modules? This operation is done in everyday life. It is done in everyday life, whereby for you to increase efficiency, you need to break down your operation into modules or into departments, right? You can't have everyone doing the same thing. If you're a Christian or a Muslim, you have someone who will preach, you have someone who will do the announcement, someone who will usher you in, different departments in the church. If you are in the university, you have different offices, different departments actually handling one section or the other. A department to handle student affairs, you call that the DSS office. Another department to deal with admission, you call it the admission office. Another department to handle the result of students. You understand? Let's say the record office. Another department to teach. Even our department, electrical, that's a unit to teach students, right? So it makes the operation very smooth, very smooth. And if you're having any issue, you know the right department to go to. If it is clumsy, everyone, a particular person doing everything, it's you cannot be able to track where issues are, right? So in production, you have to break down your tasks into what? Into a section or into different what? Into different line. So we all know this the theory propounded by Adam Smith in economics, right? Where it's talking about everyone having the same different units, So let's move on. So what are the advantages of using functions? What are the advantages of using functions? Number one, it helps you to logically organize. It helps you to logically organize your code, right? All your codes are handled by a particular function. Each function handles the section of your code. So it makes the main function very it makes the main function very simple, very organized. All right. So another advantage which is very important is code reuse. Code reuse. Someone else has written a code. Why must you write the same code? If it is functional, just import the code and use it. So it saves you faster development time. If you've written a code, maybe for a particular bank, let's say you are the one that designed a particular web interface and a particular function in the web. You are the one that designed it, and you use it for, let's say, First Bank, and the same structure is needed in Union Bank. Just tweak, just edit, just import the code, right? So it saves you what? Time. It saves you time. You have to reinvent. You don't need to reinvent the wheel. You don't need to reinvent the wheel. Doing what someone has already, you just move on from there, right? You import it and you move on. So it's easy to debug and maintain code. Now, because it is compartmentalized, you'll be able to fast track your debugging. Now, as you can recollect, initially, I said, okay, if you're running this entire code and you noticed an error, then you go to your code. You can delete this find average. You can delete this find average and this right result, and just run this get tree result. When you run this get tree result, you are very sure that you have to get tree result. If you are not getting tree result, you know that is where the problem lies. It is in this function that the problem lies. Then you have to go to that function and what? And debug. Are we on the same page? You have to go to the function and what? And debug. So if maybe in the process of executing your program, you saw that what the output of your program is not right, then you need to know that, okay, I've been able to successfully get 3 scores from user, but the computation is wrong. Then you go to the find average function to what? To look at the code once more. You don't need to look at the entire code. You need to go to that section. Okay, it's just like this. If you're having issues with admission, you don't go to the dean's or DSS office or to the VC's office. You go to the admission unit. Do you understand? If you are not receiving lectures, you don't go to the DSS office or to any other. You go to the lectures, office. Let's say to the department. From the department, it's now narrowed down to, let's say, the course lecturer. So it really helps you to really debug and maintain your code. You know which section you are having issue. So while debugging, you can actually comment some functions out and look at the specific function where you are having issue. So faster team programming. Well, the beautiful thing about programming in large production is you have teams of programmers working on a project, working on a code. So when you have teams of programmers working on a code, different programmer will be handling different units, maybe writing a particular function. Let's say I'm designing a code, a software for a soccer or a game application. So a particular team might be handling the game engine, the code that will actually make the software work, right? The game engine, the real code that deals with the physics of the software. Another team might be working on the user interface, right? Another team might be working on different sections of the code. At the end of the day, you integrate them. So with function, all what you just do is, someone has written a code, you just import or integrate it to your own code, and everything will start working, right? So that will actually make team programming faster, right? Okay, just imagine a robot. Now you're building a robot. Someone might be handling the robotic arm. Someone might be handling the robotic leg. Someone might be working on the robotic brain, eye, vision or machine learning of the robot. At the end of the day, you fix those modules, those sections. Those sections are called modules. Or what you're doing is what we call modular programming, whereby everybody is working on a module. At the end of the day, you integrate them, you bring them together, and it forms your full stack robot. So when you're using function, it makes the programming, team programming faster. All right. So what is the format in writing a function? What's the format for a function? So the basic format is you are going to have what we call the return type or the return data type. This return data type specifies the data type of the value you are going to return. In any function, you can only return one value. You can only return one value, but you need to ask yourself, what is the data type of this value I'm returning? Is it an integer variable? Is it a floating point variable? Is it a character? Is it a Boolean? Is it an array? Is it a class? You need to know, right? So then your return data type will be either int, float, whatsoever, depending on the type of value you're returning. And if you're not returning anything, you simply write the return data type to be void. I'm not returning anything. It means void, nothing, empty, right? Now, another format, in the format, you need to give your function a name. You need to give your function a name so that you can adequately call the function. You can adequately call the function. So the function should be given a name, a very, very descriptive name that relates to what the function does. So if a function is computing an average, right? Or what the function does is to compute an average score. You can say compute underscore average, right? Because you need to give it a very unique name. As you begin to write, you might have hundreds or thousands of functions. If you don't give it a name, you won't know how to call the right function, all right? So another thing is you have to have your input data type and name list. What is the data type of the input? The input data type, you have to put it here and the name. So you can have more than one name list, right? And this is the body of the function. This is what the function does. You know, you have to write what the function actually do. So you have to specify the body of the function. Now, let me explain this in a more better way. In engineering or in life, there's something we call the input output processing. So just look at this function as human or as a machine. As a machine. Example, let's say the function is a blending machine, blending blender. We all use blender at home, right? Or a grinding machine, right? So just take this, just take this as my own descriptive blender. Just don't, do you understand? Okay, so in engineering or in life, you always have what we call the input. You input some variables or some values into a process, into a function, right? So let's say for my blender, I put some tomatoes, some onion, some garlic, some ginger, whatsoever. I put it inside the blending machine. Now, you need to note that the tomatoes I'm putting is different from my ginger. It's of different data type, right? So it can be int tomatoes, right? In tomatoes, I can say this is character ginger. I can say this is float, float, garlic, and the rest, right? I put it in the blender. This blender is accepting parameters, is accepting input, right? Is accepting input. Now, when you pass in argument or inputs to this blending machine, the blending machine will carry out its own function. What is the function? To blend it together, to mix it, thoroughly mix it together. And then you have what we call the return. Let's say our tomato paste, right? So it will give you an output. So you have what we call the input, the process, this will process it, and you have your output. Now, your output is more like a feedback. It's more like a feedback to the user, right? So in function also, look at this section as what? As input. Look at this section as the input part of this of your code. Whatever you pass to this function will be accepted by this input aspect, right? Now, what will the function do to the input? It will process it. The processing is done by the body of the function. Now, when the function is true, it's going to return what? The result, the output. So the output is sent back to the user by using what we call a return statement. And now the output, we need to ask ourselves, what is the data type of the output we are returning? Is it a character? Is it an integer? So that will inform the return data type. What is the type? What is the data type of the return value? So that is what will inform us about this. I hope you're following. I hope you're following. So look at yourself as a function. Look at myself as a function. Myself as the main function. You are a sub. You are another function. I want you to solve a particular problem for me. I give you the work to do. Let's say the homework or a classwork. The homework I'm giving to you, you can see it as input argument for you to work on. Input argument for you to work on, right? After you've worked on it, you are going to give me feedback, right? So the feedback is done by the return statement. So let's move on. So the return type is the data type such as int, float, or double, character, whatsoever, of the value of what? Of the value returned from the function. So whatever you are returning from the function, what is the data type? That is what would define our return type. And I want you to note that in functions, we can only have a single return data type. You can only return a single element. As we move on, you will see how we can return more than one element. We can only return a single value or a single element. All right. So this data is returned to the program using what? A return statement. Using a return statement. Okay, so when you use a return statement, the compiler understands and say, oh, you are true with whatever you're doing. Oh, so you want to return, you want to give feedback back to the main function. So the function name is the identifier or a name. Hello? Hello? Are you having any question? Are you having any question? Do you understand so far? Okay. I want you to mute your mic if you are not asking a question. If you're not okay. So all right. So the function name is the identifier or the name of the function. Okay, the input data type and name list is the list of the input variable data type and the name and the names the function receives. Okay, so these inputs are referred to as arguments. So as time goes on, you'll be hearing me saying argument, input parameter. I can say input parameters or input argument. Whatever you are passing to this function to work on will be accepted by this section. This section talks about the input arguments, right? So let's move on. So for example, we might have a function called addEmUp. What's the function name? addEmUp. That's the function name. The function name is what? addEmUp. What are the local variable that belongs to this function? Int A, int B, and what? Int C. So whatever you pass to this function, let's say you call this function and you want to give this function a task to add some value. Let's say you want to call the function and say addEmUp. addEmUp. You call the function and you pass, let's say 2, 5, 6 to this function. Do you understand? So this in the main function, you call the function and you pass. These 2 will be accepted by this variable. 5 will be accepted by this variable. And 6 will be accepted by this variable. So it's more like saying int A equals 2, int B equals 5, int C equals 6, right? So A, B, and C now have a value 2, 5, 6 respectively. So this local variable called sum will help you add the values together and you return the sum, you return the result. Sum is the addition of this three, and you return it. So what type of data are you returning? You are returning what? It's an integer, right? So that's why this is what? Integer. I want you to also note that these are local variables. These variables belong to what? To this function. So they are more like the gatekeeper. Whatever you're passing will be accepted by this function. Just imagine this function is more like an office, and these variables are more like staffs that welcomes you and accept whatever request you're passing through. So whatever you pass will be accepted by these variables and will be worked on by the body. So the function is passed three integer values, right? These function values are then added and sum, and the sum is what? The sum is returned, right? So when you call this function, what you should be receiving at the end of the day should be what? 7 plus 6, which should be 13. So when you call this function and you pass in this argument, what you should be receiving at the main function should be what? The value what? 13. So let's move on. Let's look at another function. We are giving you examples of functions. And what I want you to note that depending on the nature of your program, that is when you will know if your function is going to have arguments or not. So looking at this now, write them out. The name of the function is what? Write underscore m underscore out, right? The function is having a local variable small that is declared int and another variable declared as big. You can see that here we are having two arguments or two parameters or two local variables. Right? So what does the function do? What's the task of the function? The task of the function is just to display to this console the big number is whatever you pass. So whatever you pass to this function, let's say your double will be displayed there, right? And the small number is whatever you pass to this function here will be displayed here. So if you have write m out and you pass, let's say 2, because 2 is an integer, and you pass 10.5, you pass in 10.5. So what you will be having is the big number is 10.5 and the small number is 2, right? So this function, because it is displaying to the screen, you are not asking it to compute anything. So it's not returning any value to you. It's not returning any value. It's just to display to the screen. So the return data type is what? Is void. Here you are computing in this function, and the function is returning the sum to you, the addition of the three integer values. And because it's returning, you can see it has an integer value. So that's it. So the function receives two inputs. 2. How is it 2? In small, 1, double big, 2, right? Input argument and integer small and double big. The function is to write this value to the screen. Since the function simply writes a value and does not return any value, the return type is what? Void, nothing. And there is no what? And there is no return statement. There is no return statement. All right. So you did not see return whatsoever here. There's no return statement. All right. So let's move on. Let's look at this function. The function's name is what? Get underscore age, and you're not passing anything to the function. But what is the function doing? The function is asking the user for what? For age. So the function is asking the user, how old are you? The user inputs the value, and this function simply returns the age. So because the function is returning age, what is the data type of age? The data type of age is int. So it means this return data type is also what? It's going to be int. Assuming you declare this as float age, the return data type here will be what? Will be float. Do you understand? So in this function, we are not passing anything, but the function will simply ask you, what is your age? How old are you? Right? So you can see the function does not have any input argument, but it asks the user for his or her age and returns the value to the user. Right? The void data type, return data type says there are no, okay, the void input here, it means there are no input arguments, right? You're not passing anything. So is either you write it as void or simply make it blank. You can just make it blank like this. Get underscore age, you can type get underscore age, you know, and you make it blank, or you write void. Void means nothing. The art was without form and void. So, okay. So since the input parameter list for the get age function is empty, no parameter is being passed, it can also be written with an empty parenthesis. Okay, let's move on. So I want to explain what we call the calling and the called function. So now I want to explain the concept called functions. So the term calling and called functions are often used when referring to functions. So sometimes you will see me use the word calling and called function. So when a function, in the course of programming, sometimes you will want a function to call another function. So when a function, let's say function 1, accesses or calls another function, function 2. Function 1 is what? The one calling. So is the calling function. Function 2 is what? Is the called. So look at this runner now. One is passing control to the other. So this is the one calling it. Is the one calling the other one. So when a function calls the second function, the second function simply takes the control from the first function. So the first function is saying, okay, I want you to do this for me. Take the control. So when the second function is true, working, it returns the control back to the first function. So the return, the feedback is done using what we call the return statement. Is done using the return statement, right? So look at this main function. This main function is now calling compute function. So control is passed to this function. So the compiler will simply go to this function, create its own local variables, execute, and when it is done, it simply destroys it and exits. So the time calling and called function, you need to understand. Sometimes this function will also call another function. Inside the body of this function, it will call another function. So it means this function becomes the calling function, while the third function becomes the called function. So you need to understand the sequence of operations, right? So I might give you a task to, okay, do this assignment, and you give the assignment maybe to your subordinate or to your friend. So at that point, I'm calling you, you became the called. When you call someone else, you became the calling function, and the third person, the third personality is the called function. Okay, so we have different type of functions. We have what we call the library functions. So these functions are the inbuilt functions provided to the programmer who writes C++ program as it saves the programming time. So for example, in the CMAT library, we can use the square root function, the power function, the exponential function, the logarithm function, the sine, cosine, tan, arctan, and the rest. So you can use this. So all what you just do is you just include the CMAT library, #include CMAT, right? And you just call the function and pass it. So for this function now, I can call it and passing the value of, let's say, 25. So the result is going to give me a feedback. It's going to return a value to me, and the value should, as you've expected, the value should be 5. I can pass it 16 and it returns 4. I can pass it 100 and it returns 10. I can pass it any value and gives me. So I don't need to write a function to compute square root. Why should I write it? It's already given to me in the library. Or what I just do is to include. It's more like I'm importing. Is to include the CMAT library, and the CMAT I will be able to use the function. Do you understand? It offers. Okay, so you don't need to reinvent the wheel. It saves programming time. All you need to do whenever you want to solve a problem is to use what? The right function. So we have another function called the user-defined function. These are the function you or me write ourselves. Is user-defined. Those are bespoke functions. So the programmers can introduce user-defined functions into the program either by including an header file or by adding the function block directly to the program. All right. So what are the requirements in writing function? We have two models. Because you might pick up a textbook and you see one model, okay? But the second model is what we will use in this course. So the model is, there are 3 required statements whenever a function is used in C++. And it means that every function must have what we call a prototype statement, a function call, and the function header line and function body. We will explain that as we move on. So the prototype can be thought of as a model or a pattern that tells the compiler the function name, the return, and the input type. Before you use a function, do you understand? Before you use a function, the compiler should be aware of the function. Okay, if I come to your house and I want to pick up certain thing, whoever I will meet at home must be aware of my existence or my personality, right? You must have told the person, oh, the name of the person, the function name or the name of the person is Engineer Adeniyi, okay? Is going to bring something, is not going to bring anything, no? That means the input is input argument, or is going to return, give us something or deliver something to this house. Do you understand? So you must have prepped the compiler about the function. You can't just like you cannot use a variable without it being declared, right? The compiler should be aware of the existence of a variable, likewise of an existence of a function. So the person coming to deliver will be told his name is this, the company is this, blah blah blah. So the prototype statement can be thought of as a model or a pattern that tells the compiler the function name, the return type, and the input types. The function call is the location in the program where the function is being called. So if you are calling the function in the main function, that that is where the function is being called. That's where the first statement. And the function in that line and body is the actual code that the function is, that the function is performing or will execute. Right? Now, in the function prototype, you are just describing or making the function aware. In the function header line and body, you are simply explicitly writing what the function will do, right? So that is that. Okay, let me give you an example. If I want to create my function, my own user defined function. In this time, I will give it a prototype. Okay, in this case, the prototype is write hello. What I'm saying is this function write hello. I'm not going to pass anything to it, but this function is not returning any value. So you simply type void the function name, and since I'm not passing anything to it, you can just simply make it blank, the parentheses to be blank, or you can type void. Okay. Another function, get age, because I'm going to get age from the user, right? I'm not going to pass anything to the user, but the user is going to return a value, right? It's going to return the age. So what's the data type of the age in? So you can see the format, because the format is return type, the function name, and the input type list. So I want to write age to the screen. So because the function is just writing to the screen, it's not performing any computation, it's not returning anything, so it's void. What's the name of the function? The name of the function is write age, right? And I want it to write age, but what age does it want to write? It means I'm going to pass it an argument, right? So I'm going to pass it an age. So the function will be write age. So the data type of the function of the variable I'm passing into the function is what? Is integer. So look at this. Here in the main function, I'm calling the function. This is where I'm calling the function, right? This is the call statement. This is where I'm calling the function now, right? So I'm calling write hello. Write hello will be the first to be executed, the first function to be executed, followed by get age. If write hello never finishes its computation, get age will not execute. When you go to the bank, the first thing it prompts you is to input your PIN, right? If you never input your PIN, it will just stay there. It will not take you to the next task of, okay, what transaction do you want to perform? It will just stay, it will lock you there, right? Until you input your PIN. Maybe you might have, in your code, you might have put a timer there and say, okay, after 30 seconds, if this guy is not putting in his PIN, just exit, right? But what I'm trying to tell you is it will not execute without, the next function will not execute if the first is not true. Oluwatobi Loba, Oluwatobi Taiwo. Okay. Can you unmute yourself?
Okay. Yeah, I
Oluwatobi,
just want to ask a question, sir.
feel free.
Okay, so I don't know, you may want to go back to the slide you were explaining before you switched to this one.
Is it this?
No, the place where you add the proto. Okay, yeah, this one.
Okay.
So you said this void write hello int. No, not this one, sir. Not the requirements.
Is it this?
Okay, yes. This, how old are you? Yeah. So you said the first listed called function are the prototype. They are not actually called. Right?
Yes.
So if I want to like write the the function that holds writes hello now, will it be within the int main
Okay.
function, or I'm just going to write it like directly under
I will explain. We'll get there. We'll get there.
right?
Okay, but now let me quickly explain this to you for the sake of some of you that will read wide. Do you understand? Okay, you know, I told you that what's the requirement? The prototype statement. The requirement is the function prototype, the function call, and the function header line and body. And I told you that the function header line and body is the actual code. It tells you everything about the code. It tells you everything about the code. Now, this is the function prototype. This is the function call, right? Where is the function header line and body? This is the function header line and body, right? So I want to explain one key thing to you, that we have two school of thought. You know, I was silenced on that. We have two school of thought, and one school of thought states that, okay, whenever you want to write a function, simply write the prototype, you know, and after the prototype before the main function, right? Or the prototype as you go on, the prototype will be in another file, in another header file, and you now include the header file here. As you go on, you will now do hash include the file name. You will now include the file. As you go on, this prototype, right, will be taken into another file as you go on. But now, where am I going? Where I'm going is this. A school of thought or a programming paradigm states that, okay, you need to have the prototype statement, the function call statement, and the function header line and body. But another programming paradigm will say, okay, simply if you bring the function header line and body before the main function, the function header line and body before the main function, the compiler is aware of everything about the function. So it means you don't need to specify the prototype anymore. You don't need to specify the prototype. So I know everything about you. I know your return data type. I know your function name. I know the argument. I know the body, what you will actually do. So why should I write the prototype? But for this program, for this course, we want to stick to this program paradigm, which states that you need to define the function prototype, the function call statement, and the function body. Now, this function, write hello, what does it do? With this code now, you don't know what it does. You don't know. Oluwatobi, are you online? Are you still online?
Yes, I'm with you, sir. I'm with you.
Yes. With this code now, you don't know what the function does. Can you tell me what it does? You don't know, right? So what it does is now explicitly written by the function header line and body. So this is the function header line, this is the function header line, the line header line. Can you see that the function header line is synonymous or the same
So
or
the
synonymous
prototype.
with our prototype? Void, yes. Void, write hello. Can you see? Void, write hello. Now, what is the function doing? What's the function body? What this write hello is doing is just to display to the screen hello world. So what the function is doing is to display to the screen hello world. It's not doing any other thing. Are we passing any argument to the function? Are we passing any argument to this function? No, the function is not accepting anything. Are we returning anything from this function? No, we are not returning anything. Because we are not returning anything, it's simply what? Void. We can come here and type void, right? But you can just leave it blank. Okay, look at get age. Get age is asking the user for his or her age, and it returns the age. So look at this. Get age, we're not passing any parameter to it, no input argument, right? We are not giving it a task to perform, but the function simply asks the user, how old are you? right? Simply ask the user, how old are you? So the user input is age here, and the age returned to where? Where is the age returned to? Anyone? The age is returned to the main function. The main function is the one calling this function. So see the main function as the boss. The main function is the boss of the all function. That's why they use the word main. Main, the oga, the main, the superior of all functions. So this function calls this function. So get age is being called. So any value the get age is going to return will be stored where? Will be stored in the age. Do you understand? So write age also.
No.
Write age receives the age that was input by what? Get age, and it simply writes the age to what? To the screen, right? Because it's just writing the age to the screen, it's not returning anything. So you cannot see any return statement here. There's no return statement here. So the return data type is what? Is void. Do you understand? Okay. As we move on, you have better understanding. So look at this. So see the main function as the boss of all functions. So you can see here in the function call, this section is what we call what? The call statement, true or false. Okay, Oluwayomi David. Oluwayomi David, can you please unmute yourself?
Hello, sir. Good morning, sir.
Yes. Good morning,
Yes,
David.
I want to, are we supposed to write this code where we call the functions first, or we are to do the ones where we have the functions itself before the ones we are to call from?
Okay. Now that's a very good question. The first thing you do is you define the prototype, the function prototype, right? You can then go to the function header line and body. Do you understand? You go to the function header line and body. When you're now through with the function header line and body, then you can come. Someone, I don't know. I can hear some noise in the background. Can you please mute yourself? Someone is on the road also. Okay. All right. So you write the function prototype followed by the function header line and body. Right? Then whenever you need a function, you simply call the function. You now move to the function call. It's just like you can be at home, you can be sitting in the sitting room with your parent and you'll be redundant, right? It is until your parent needs you that he calls you, that they call you, right? So here you first of all write the function header line and body, then followed by the statement. Now, I want you to understand that it is a very good programming practice to always write and run. Do you understand? And run as you go. You don't need to write all your code all at once before you test them. Do you understand? So they call it unit testing. They call it unit testing in programming. Unit testing. You test this unit. You first of all write hello, and you test it. Is my write hello working? So this is what I will do. I'll first of all specify the prototype statement, followed by the write hello body. Then I will now call it to see how it will work. So I'll write the write hello. So I debug and I see that, oh, write hello is working. Oh, okay, that's good. do I come to get age? The beauty of that is, if assuming you are coding, you are the exam hall, and at least you will still get marks. You still get marks as you move on. So you still get marks as you move on. So are you with me, Oyetoro?
Yes, sir.
Okay. So do you understand what I'm saying? So you can have function. It's just like you can have a genie. Just imagine you have a genie. The genie can perform the function body. The genie can perform anything that you ask him to do. But it is until you call the function, you call this function, that the function gets executed. Now, just imagine, just imagine I call this function before I call get age function. I'm going to have issues, right? Because where do I have parameter to pass to my right age? So you must know the order in which a function is needed. So, and the function will be called, any function you call first will be called before the other. So right hello will be called first, followed by get age, and followed by right age. Are we on the same page? So a function will be idle. A function will be idle until you call it. Until I call Oyetoro, that's when you answer me. That's when you execute and say, sir, yes, sir. Yes, sir is more like an execution. Yeah, that's when you execute, right? It is until I call you. So the chain of programming is, you have your prototype, you have your function header line, and you have your function body. Okay. So except from the main function, all functions in C++ must have a function prototype. Yes. The function prototype is a declaration statement that provides the programmer with information about the input, the function name, and what the return data type. Variable names can be included in the input parameter of a function prototype also, yes. So to make things better for you, to make this better for you, when you are writing a function, right, just simply copy the header line. Just simply copy the header line and put it as your prototype, or copy your prototype. Because let me tell you, as you continue to program, as you begin to program, you will start making some mistakes. One of the mistakes is you will be having type mismatch. Maybe in your prototype, you said right age will be int right age. Int right age. You might have written in your prototype that the return data type for right age will be int right age. And you come into the function header line and body, and you write void right age, and you forgot to to correct your mistake. You'll be having issues like that. So before a function can be called, the calling function must know about what the call function. And how does it know? It knows due to the what function prototype. Okay. So a function prototype may be declared in the calling function before the call. It can appear above the calling function or inside an include file. As you continue to master your art in programming, you will take the old function header line and body, and even the function prototype, you put them into another file. So the function prototype will be in an header file, right? So in the header file, you now do #include. You understand? You now include the file into any code you want. So, so the most important point is that the compiler must have seen the function prototype before the function is called. And so what's the format? What's the format or the form? Your return type, your return data type, the function name, and the input what? Parameter type. The input type list. List in the sense that you can have more than one input. Depending on the function. That's what will determine what your type list will be. Okay, so look at the prototype. So these are the prototypes. They are always declared before the main function. Before the function, inside the main function, that's where we have the call statement. So the compiler must have seen this function, must be aware of this function before you call it. So how does it become aware? It becomes aware in the function what? Function prototype. So they should have be located so that the compiler sees or knows them before it calls them, right? Okay, you can't call someone you don't know. You must have known someone before you call the person. So let's move on. The call statement is the statement located in the calling function where the called function is accessed. So when a function is called, the control is passed to the called function. And the statement inside the function, that is to say the function body are what? Are performed. So when the function is true, it simply returns the control back to the what? Calling function. You see, when I call you or give you a task, you must perform the task and give me feedback, right? I pass in tomatoes, garlic, ginger, whatsoever, maybe nutmeg, whatsoever inside the blender performs its task, and the blender simply returns, give me a feedback, an output, right? It gives me a feedback. So from this diagram, you pass in input, it processes it, gives you your feedback. So the function calls the input. So when a calling function must pass information to a called function, right? The actual value of variable name are used in the argument. So this is the function call statement now. So I want to call this function to perform a task for me. I must pass in an argument if the function needs an argument, right? The argument will be what? A variable or a value. So I can say write age and I say 2, right? It means I'm passing 2 to this function. Or you can pass in a variable name. As you know that a variable name is the name given to a location, right? So there's a value in that location. There's age might have a value of 10. So what you're doing is you're passing 10 to this function. So a copy of age value, a copy of age what? Of age value is passed to what? Is passed to the function. So if the function does not have any input value, the parentheses are what? Are left empty. So if I want to write hello, because write hello does not need any value, the parentheses are empty. Get age does not need any value, the parentheses are open. So the call statement also, the return statement, we're talking about the return value. How does the called function return value to the calling function? So the return value of a function must be assigned to what? To a variable in the what? In the calling function. So now when this function is called and it's executed, I'm coming, just give me a second. So if I call this function now, if I call this get, okay, if I call this get age function, the get age function will execute, and the result, when it performs its tasks, it will return a result back to the calling function. Do you understand? So the value returned must be saved in a variable. So in this case, we are saving it in a variable. We are saving it into into a location called what? Age. Are we on the same page? We are saving it into a location called age. Now, so if the function is not returning a value, so no assignment is needed, right? You don't need to store anything. So in this case, the write hello function is not returning any value. So we are not assigning anything to anything. We're not assigning, it's not returning. So there's no assignment. Write age is not returning. It's not giving us a feedback. There's no return state. There's no assignment. Okay. So the function header line and body. So like I said initially, we have three requirements. The first requirement is what? The function prototype. The second is the call statement, and the last one is function header line and body. But I want to tell you, I need you to understand that the function header line and body should be written secondly before the call statement, or you can write the function header line and body first before the main function. So there will be no need for you to write what? The function prototype. Okay, so the function header line and body is the first line of action. So
Sir,
yes.
I thought you already agreed that we should stick with prototype, then the function header line and body, then the call.
Yes, yes. That's what, see, let me tell you, one of my attacks is to give you everything. Do you understand? I don't want you to pick up a textbook and you don't understand what this textbook or what this person is saying. But you need to stick to what? The function prototype, the function call statement, and the function header line and body. Do you understand?
Yes,
Do you
sir. Yes,
understand?
sir. Yes, sir.
Yes, that's the reason why I'm stating that. I don't want to give you a style, and at the end of the day you can find another thing in another textbook. That doesn't mean this is the standard. This is the standard. Okay. So let's move on. The function header line body has what? A return type, a function name, and input parameter list. So the function header line, the function name is add-em-up function. The function name is what? Add-em-up function. The local variable belonging to this function is what? Int A, B, and C. Do you understand? So this int A, B, and C, they belong to this function, and they are local to this function. So this is the function body. So you can also see that in the function header line and body, we have what we call the return data type. So the return data type is an integer, data type. So it means this function is returning something, right? So what is the data type of the sum? What's the data type? The sum is what? Is an integer, right? See, as you begin to program, you might make some mistakes. You might make some mistake in, you might give your variable you want to return. It might be a float. This might be a float, and here you declare it as an integer. It's going to give you an error. It will give you of any variable you want to return must match the return. Yeah, it must match it. It must match it. So another thing I want you to understand are that these variables belong to this function A, B, and C. Just imagine that A, B, and C are like staffs belonging to this function. Add them up. Their task is just to accept requests. So if I call this function in the call statement, I call this function add m up, and I pass 3, 5, and 10 to the function in the call statement. when I pass it, these values must be received by a variable. They are received by these variables, right? So it means A has the value of 3, B has the value of 5, C has the value of what? 10. Then you can then add them together here to give you 18, and you return the value called the value 18. So if you call this function, the value you should be receiving or saying in the main function should be what? Should be 18. So when you call this function and you pass in this argument and the function gets executed, what you should be having is what? Is 18. 3 plus 5 plus what? 10. So just imagine these variables, they are more like a staff of this function. They are more like a staff belonging to this function. So when you as students goes there and give them your data, your information, they simply, okay, add them together and return value, okay? So like I said, add them all in the add them all function, the argument or parameter has 3 integers. Writing these 3 variables, A, B, and C in the function header line is a declaration. We are declaring the variable, true or false. And again, the variables belongs to what? The function. And I want you to know that the return statements returns a value to what? The calling function. If the function does not return a value, as we said earlier on, there is no need for return statement. You might make some mistake of writing many return statements in a function, but let me tell you, it's only one that will be executed, because you can't call if you are having, let's say, return A, do you understand? Semicolon, return B, and return C. Let me just leave it in this aspect. Returns simply states that, oh, I am true. This function is true with its task. The function is exiting. I'm through with my work, I'm exiting, I'm closing up. The function will now return this value back to the main function and simply exit the function. So at this point, at this level, the function has exited. This function is no more in scope. So it will not execute this because the function is no more valid, does not exist anymore. So sometimes I might ask you, okay, write a quadratic equation, write a function to accept 3 coefficients of a quadratic equation. And some of you will write return A, return B, return C. It will not work. It will not work. So you need what we call by reference to actually solve the problem. Or you can have a function called 3 times. So you can call a function return A, it will accept A, another function to get B, the coefficient of B, and another function to get the coefficient of C. So like I said, we're talking about the evaluate a value. So if you pass in A, B, and C, rather than creating in sum, another variable in sum, right? And start writing sum equals A plus B, sum equals A plus B plus C, right? You can just use the return statement in this format to say return A plus B plus C. And you remember in our operators precedent that bracket, or just in your board mass, bracket is first of all evaluated first. So it will evaluate this first, A plus B plus C, and then return the value. So it means in a single swing of a wand, this return statement is doing 2 things. It's first of all doing the computation and also returning the value, right? So look look at this function, write hello. Write hello does not have an input argument. Do you understand? Does not have an input argument. So it's simply writing hello to the screen. It's not returning anything. So there's no need. There's no need to write a return statement, right? There's no need to write a return statement. So okay. The same thing I've explained. There's sometimes if you want to exit a function, we use what? A return statement. So if you want to in this way, you want to find if a number is even. So if you find the modulus of this, if it is even, the value will be 0. So if it is 0, simply exit this function. We are out of here. You understand? So a return statement can be used to return a value or simply exit a function. Okay. So Taiwo, can you please speak up? The floor is yours. Shabi.
Okay, sir. Yes, sir.
Okay.
So I wanted to ask that how do I properly call the add up function? That is the one we just looked at. And I asked this because I just tried to run the code and then I got an error because I just called it there. And it seemed like it just did not immediately display the value, like the sum of the numbers that I put in. So am I supposed to maybe now put that function as if now declare a variable which would have the value of the function or something like that? I don't know if you understand my question, but what I'm trying to say is I tried to run the code and then
Okay.
I created the function add them up, and I already called the function and I already put the arguments in the parentheses, like the 3 numbers,
okay.
the 3 integers.
I'm trying to.
So I just tried to run it.
Okay. Now let me use this function as an example. So if you call the add them up function, just okay. Let me look for add them up somewhere so that.
Yes, like this part.
Call this. You pass in an argument, let's say a value 3, 5, 6, a value. Did you do that?
Yes, so I passed in 2, 3, and 4 something. 2, 3, and 4, or 3, 5, and 6. I'm sorry, am I the only one that can't hear?
No, I think the network.
Everybody can hear.
Okay, it's not first.
Hello?
Yeah, we are with you, sir.
Okay, thank you very much. Thank you very much. Shabi, is it Shabi? Are you online? Are you still online?
Yes, sir. Yes, sir. I'm
okay,
here.
Now.
Yes, sir.
In the main function, did you call the function add them up with any value of your choice?
Yes, sir. Yes, sir. I did that already.
Okay, if you done that, this function body will return a sum, right? True or false?
Okay. Yes, sir. Yes, sir. True.
In the function body, did you save the return value into a variable? Let's just say sum. Did you save it?
Yes, sir. Well, sum equal to a plus b plus c. Basically, what's in this slide, what you explained. So I just typed it as it was shown.
Okay. Let me do something. Let me do something because. Okay. Now, did you now write a function to display the sum? Did you write the function to display the sum?
A function.
Did you write a function to display the sum? Yes. Okay, you only computed the sum. You only computed the
Yes, sir.
sum. Did you
I
write
just
a function
created
to
the
display the
function.
sum? Did you
Oh,
do that?
okay,
Is
to
it giving you?
display it.
Yes, you've not
Okay.
asked the
No,
compiler
I
to
don't think I
display.
did that.
No, it will not. You just computed. It's just like telling me, okay, add this thing together. Understand? So if you never write a function to
Yes, sir.
display the sum, it will not display. So let me find. Okay, look at this now.
Sir,
What you did is to let's just say to get the. I'm sorry, there's an event in my area. I'm very, very sorry. So if you ask to get age, if you get an age, do you understand? And you save the age into a
yes,
variable,
sir.
you need to write the age to the string, right? Or in your get age, you can now say see out age. You can come here,
Okay,
see out
see out.
before the return. Do you understand? But
Okay. Yes, sir.
a good
Okay.
programming paradigm to put a function to do more than one particle. Do you understand? So you can have another
Yes,
function
sir.
to write out the age for you. So you now pass in
Yes.
the age to write, let's say write sum. You can now say write sum, you pass in the sum here.
Okay. Yes, sir. I understand.
Do you understand now?
Okay,
So
sir.
it's just like
Yes, sir.
now,
I think we already did
it's just
something
like
like that in
now
the other one.
in a canteen.
Right?
Yes. So just imagine you are in a canteen, someone, the waitress accept the invoice from the customer, right? So the request, the food order will be given to a chef, right? So the chef now prepares the food. The food now given will be passed to, let's say, the waitress to serve. So we are passing variables, we are passing information. So the information gotten from this function get age is saved here, and that information is passed by this function. Do you understand?
Yes, sir.
Okay.
So I get that.
So please try to look at the code once more. You will be able to solve.
Sir.
Are we on the same page?
Yes, sir.
Okay. So
Thank
there's
you.
something called, you're welcome. I wish I still have more time to be able to do any practical for you. And okay. So this is explicit enough. Called by value. So anytime you're passing a variable, to a function, you're also passing a value to the function. Do you understand? So in this case, assuming the value gotten by the user is 5. Do you understand? It means you're returning 5 back to the main age. So this age will be what? This age will be 5. Now you're passing age to this right age. What you're doing?
Excuse me, sir.
Yes.
I can't see your screen. I don't know if you've stopped sharing it.
Is there any other person that have not seen my screen?
Yes, you have.
Sir,
You are not
I
showing
see your
it.
screen, sir.
Okay. Don't worry. Let me go back. I'm coming. Please. Is anyone online? I want to get feedback if you can hear me.
Yes, we can hear you.
Yes,
Okay,
we can hear you.
Yes, sir.
Can you see my screen now?
Yes, sir.
Yes, sir.
Okay. Now, I want you to see the line of command, the line of execution. Now, when I call this write hello, this is the function body. This is the function body. There's no data passed to this function, right? So you can see this function body does not have any value. You understand? So the function simply writes hello to the screen. Simply writes hello world to the screen, right? So when it's done, it comes back to the main function. This get age function gets called. So we are not passing anything to the get age function, but the get age function is going to return an age value. So in this case, let's say the age input by the user is 5. So this 5, the value of 5 will be passed back and it will be saved by this age. Why does it need to be passed back? So when the function is called, it comes alive. It's just like it's born. There's a lifespan for a function. It gets called. When the function is called, it gets born. The function is born. It quickly set up its variables, right? When it is done, it simply returns. When it returns, the function will die. The function will be destroyed, will cease to exist. So if it ceases to exist, if you don't save the value to a variable, the value will be lost. So if the value is lost, it means you won't be able to work on any data. You won't be able to work on any data in the main function. So the data now gotten by the get age is now written to the screen or passed to write age. So here, that 5 will now be passed here. Do you understand? It will be accepted by this age. Will be accepted by this age. Do you understand? So the 5 here will be passed to this local variable. So it's more like its age equals what? Equals 5. So then you can now display you are 5 years old. You can see how we are passing information from one function to another. So how do you return information? You use return statements. You understand? So the function requirements, and the C++ library. In C, there are 18 libraries. In C++, we have about 50. Do you understand? So if you need any functionality, you have to use the right library. So just like the math library provide a square root function, it provides a cosine function, a sine function, a logarithm function, exponential function. Do you understand? So all what you just need to do is to include the math library right here, and include C math. Now this is for C. This cmath.h means include a math header file. This h means header file. Do you understand? The h means header file, and this is how you include libraries in what? In C. In C++, you use CMath, standard library cstdlib. Do you understand? And the rest. So this processor directive, this hash include is called a processor directive. Tells the program to look in the what? Math file. Oh, I do. Now, what happens is when you say square root, the compiler will say, oh, I don't understand this function. I've not seen this function before. But with this, you are telling the compiler, go and, if you don't understand this square root function, go and check in this math library. So that's what it is saying. So, and the compiler includes the math library when it is what actually compiling the code. So we're going to talk about the local static and global variable, and then we are through with our class. So let me quickly read the statement because of time. C++ statements within functions are hidden from other parts, right? The only way, just hold on, I need to address some noise. So please, the old variables in function is by calling the function and having the function program enter through the function header line. So we cannot perform a jump function in the middle of jump instruction in the middle of a function. So let me just, the scope of a variable is determined by the location where the variable is declared. I want to explain local variable, static, and global variable. So the scope, the visibility, how you can use a variable, or to an extent where a variable can perform, it's determined by the location. If you are a Nigerian citizen, all your rights, all your scope and your privileges is limited within Nigeria. You can't go to Ghana and start saying you are Sunday Igboho and you want to operate there. Do you understand? You are not a global variable. You are local. Do you understand? So your visibility, it's limited to where you are what? Where you are declared. So what am I saying? When a variable is declared within a function, when a variable is declared within the function or in the function header line and body, that variable belongs to that function. What I'm saying is when you declare a variable inside a function, that variable belongs to that function. Or if you declare the variable inside the function header line, the function belongs, or the variable belongs to that function. So no other function is very important. No other function can see or change the variable. So they become local. It's more like a local variable. A citizen of that function, no other variable or function can see the variable. So this local variable come into existence when the function begin execution and are destroyed when the program control exit the function. Do you understand? So let's look at an example. Look at this age declared in this main function. This age only can be seen by this main function. It belongs to the main function. Its scope of operation, how you can use it, is only limited within main function. You can't use it here. So you can see in get age, we also have a local variable called what? Age. This age, this function in the main cannot see or cannot use the variable in the get age function because they don't belong. Bello, can you ask your question?
All right. Good morning, sir. Okay,
Good morning.
so I have a question about the variable scope of
Yes.
functions or methods declared in the main function or the main method.
Okay.
I thought those were the
Okay.
ones that could be seen by all classes or sorry, all functions in that class. I thought variables declared in the main function could be used everywhere within that class.
No. It can't be used everywhere. You can pass in parameters from the main function to other function. Do you understand? You can pass in parameter from this main function to other function. But what we are saying is for you to access the variable, you can't from here access this age variable. Why? This age variable is limited to this function. Look at this. Looking at the starting of the curly braces and the ending of the curly braces, this is where the variable can operate within. When you come to get age, it can, so this get age is just like this. Your name is what? Your name is what?
Emmanuel.
Emmanuel. Okay. There can be another Emmanuel in United States. Do you understand?
Yes,
you are different. You are different. So Emmanuel in United States, his scope is right, is only in United States. Emmanuel in Nigeria is limited in Nigeria. Do you understand? Because as you go on, no two function must have the same variable. No, as in no two variable name must be declared in a single function. Because when you say Emmanuel, in a particular function, the function will be saying, oh, I don't understand. Do you understand? There will be conflicts. So you can say Emmanuel 1, Emmanuel 2. Do you understand? So the mistake as you will start early programmer makes is they will say, oh, I've already declared age. So let me just use the age. No, this age only belongs to this function. Likewise, this age declared in the header line only belongs to the right age function. Do you understand? You can pass in names. You can pass in argument to the name. That doesn't mean they belong. Do you understand?
Yes.
Hope is clear now.
I was thinking that the local variables only apply to like user-defined functions, not like the main.
No. It applies to the main. Do you understand?
So,
it applies to the main. So, but you can pass in values from the main function to other functions. Like here now, you're passing the value of age to this function as input parameter. That doesn't mean in the body of this function, right age, this is there. No, this age belongs to this function. Do you understand? So it's just like this. I can say, oh, Emmanuel in main function, Emmanuel in Nigeria, go and deliver a resources, a value to Emmanuel in United States. Do you understand? The limitation, there's limitation. So when a program begins to execute, the local variable inside the function are created. So the storage space for the variables is not created until the function is called. Do you understand? And the function control is passed to it. Okay, just imagine you are building a duplex. You don't call all your laborers. You don't call all the people that will work at the same time. So you might call the people, the builders first. When the function, when the building gets to, let's say, is completed and you need to paint, that's when you call the painter. And the painter will bring his own local variables, will bring his own staffs, will bring everything to come and work with him as at that time. Are we on the same page? You don't bring, so the functions variable are declared when the function is used. Do you understand? So you quickly set up your own team to quickly help you perform the task. And when it is done, they are released from memory. So please go back to the slide and you will, because our time is almost up. So,
okay, so I have a question.
So,
yeah.
Okay, quickly.
Okay, so there are times after creating a function, once I go into the main function to call them, I do get this error message that the parameters I use in the function I created are not defined.
Yes. Look at
Must I
now.
define the parameters in the main function as well?
Now, the parameters in the main function, you have to define any variable before you use them. Do you understand? Any variable before you use them, you have to define them. Whether in the main function, you have to define them. In the other function, also you have to create your own variables. So you need to understand how the variables are returned from the other functions back to the main function. So as is returned, it will be saved by a variable in the main function. So you can't use any variable without declaring them. That's what it's saying.
Okay.
Are we on the
But
same
I
page?
declared them in the other function, but it's telling me it does
No.
not recognize it in the main function.
That is what I'm saying. They are
Okay.
local. They are local. They belong to that function. They don't belong to the main function. Do you
Okay.
understand? So you have to create the main function variable also. Even if they have the same name, no problem. But
okay,
you have to create
sir,
the main.
What I tried doing was that I tried to call the function itself, but the main function was telling me that the variables I used were not defined.
So please, this is what I will do. Maybe after today's class, I will create a practical session. I will share it online. Do you understand? So that you'll be able to see it and
Okay,
be able to learn from it. Do you understand?
Okay,
because of our time, I don't want it to just stop abruptly. So
okay, sir.
Global variable are variables that are declared outside of functions. So look at declare, say hello function, right? Is declared outside of functions. So global variable can be seen and can be accessed by all functions. So now look at this count variable. This count plus, this count variable I'm calling the what? I'm calling the global variable here. Do you understand? So that is it. I'm calling the global variable because it can be seen by all functions. I can call the global variable and say count equals 5. If I say count equals 5, it will change the value of this count automatically because it's a global variable. The variable is declared of function, especially before the main function. So that is concept. So the assignment, why is it dangerous? Because every function can see it, every function can access it and can change it. And sometimes you might not know when a particular function has altered the value of a global variable. So it must be used with what? With caution. So go back to the slide, look at it, and it will be explicit enough. Practice, because functions are very key. They are very important. You cannot do it without using function in programming. So I wish you all the best. Any question, you can, maybe I will give my number so that you can actually send me questions. So I wish you all the best. Hello?
Sir.
Thank you, sir.
Yes, sir. Thank you very much, sir.
It's good having you. Stay blessed.
Thank you,
Yes,
sir.
sir. You too, sir.
Yeah,
Bye.
Bye, sir.
Bye. So always check the platform from time to time. You will see updates on the platform.
All right, sir.
Yeah, bye.
Bye.